Hey guys, today we're going to talk about how to solve quadratics. It's a quick review. It's an important lesson that you guys need to know how to do before we start solving quadratics within the topic of trig. Now, there are a few things that are written at the top of your paper that are really, really important. Quadratic equations, because the highest exponent is a 2, x squared, can have up to 2 solutions, whereas a linear equation, like number 1, because it's only x to the first power, can maximum have 1 solution. When it comes to quadratics, they can be solved by factoring, square roots, which are called inverse operations. I call that SADMEP, the order of operations but backwards, or the quadratic formula. I'm always going to try to factor when possible. Square roots, this idea of SADMEP, you use when there is no linear term. AKA x to the first power. If you look at number 2, you've got 2x squared minus 1. Anything with an x squared is called a quadratic term. Anything with x to the first power is called a linear term. And any number without a variable is called a constant term. So number 2 has a quadratic term, no linear term because it doesn't have anything with x to the first power, and a constant, which is a number without a variable. It's really important for you guys to know that when you're solving quadratics, most of the time we're going to set them equal to 0 if they're not done so already. But the first few problems, like 2 and 3, are already set equal to 0, which is a good thing. Okay, let's take a look at number 1. Number 1 is a very simple problem. It's a linear equation. You learn to do those probably around 6th or 7th grade, maybe even earlier. Now, even though it's set equal to 0, to solve it, you're going to isolate the variables. So you start by canceling addition and subtraction first. This is called SADMEP. This is the inverse order of operations. Then you cancel multiplication or division. And then if possible, reduce. If not, that's your solution. So the solution to 2x minus 1 equals 0 is a half. How come? Because if I put this back into the original equation for x, it'll give me an equation that's true. Half of 2 is 1, and 1 minus 1 equals 0. So the solutions that you find, if you substitute them back into the equation, so you see how this was said x had to be a half, plug it in for x, should give you a true statement. Okay. Number 2. As I mentioned earlier, I use square roots, aka SADMEP, whenever there's no linear term. So number 2 does not have a linear term, so I'm going to solve it very similarly to number 1. I'm going to cancel addition and subtraction. This is called SADMEP, inverse order of operations. Then I'm going to cancel multiplication or division. Then I'm going to cancel the exponent, so I'm going to square root. And remember, when you square root while solving, you're going to have 2 answers, a plus and a minus. How do you square root a fraction? You square root the top and you square root the bottom. Square root of 1 is 1. Square root of 2 is square root of 2. You can't have a square root in the denominator, so you rationalize. And you end up with root 2 over 2. So your answer is plus or minus root 2 over 2. To check your answer, plug it back into the original problem. Two times root 2 over 2 squared, so root 2 over 2 squared would be root 2 over 2 times root 2 over 2, which is 2 over 4, which is a half. You can technically just put this in your calculator if you want to check it. 2 times a half minus 1 does in fact equal 0. So root 2 over 2 is a solution. The same thing would happen if you had a negative. Negative times negative is positive. Negative root 2 over 2 squared is a half. Half of 2 is 1. 1 minus 1 is 0. So whenever you solve these problems, if you have extra time, especially on a quiz, substitute your solutions back into the original problem to see if they actually work. All right, number 3 has a linear term. The linear term is this guy because it's got an x to the first power. When it has a linear term, I always try to factor if possible. So right away I can tell that this binomial has a GCF of 2x. So I'm going to go ahead and factor out a 2x. That leaves me with, remember factoring is writing something as distribution. So GCF goes in front. I'm going to be left with the remainders that I get by dividing each of these terms by 2x, which would be x minus 1. Remember, you should technically be able to multiply 2x times x to get the original 2x squared, 2x times negative 1 to get negative 2x. Factoring never changes the value of a problem, just changes it into a distribution, aka multiplication problem. When you're solving quadratics and you're done factoring, so this is the most I can factor, I go ahead and set each linear factor equal to 0. This comes from the zero product property that you guys should have learned freshman year, but feel free to Google it in case you forgot what it is. So when you're done factoring, each linear factor needs to be set equal to 0. You solve it. 2 times x, that's multiplication. Multiplication is canceled with division. 0 divided by 2 is 0. Cancel subtraction with addition, and you get 0 and 1. If you substitute those back into the original problem, 2x squared minus 2x equals 0, look, substitute 0, it works. Substitute 1. 1 squared is 1, 2 times 1 is 2, 2 minus 2 is 0, it works. Remember, you can always check your answers by substituting them back into the original problem. Remember, you can pause and rewind the video at any time. All right, number 4 does not have a linear term, so I'm going to solve this using SADMEP. Cancel addition and subtraction first, then multiplication or division. Reduce if possible. And remember, when you square root, and when you're solving, you're going to have two solutions. Now, the square root of a fraction, you square root the numerator and the denominator separately. Square root of 1 is 1, square root of 4 is 2, so you get plus or minus a half. Okay, the next one is a quadratic trinomial. Most of the quadratic trinomials that we're going to work with can be factored. You're going to take the leading coefficient, multiply it with the constant term, and you're going to find two numbers that multiply to that answer. So 1 times 12 is 12. That multiply to 12, but add to the middle term, the linear term, which is negative 8. So you're going to list all the factors of 12 and find two of them that will add to negative 8 and multiply to positive 12. Because the leading coefficient is a 1, I can, as soon as I've got the two numbers that multiply to the outside terms and add to the middle, I put them in parentheses with their respective signs, so it was negative 2 and negative 6. If I were to FOIL or distribute this out, I would get the original problem of x squared minus 8x plus 12. Once you're done factoring, every linear factor needs to be set equal to 0. So your two solutions are 6 and 2. Remember, you can substitute these answers back in one at a time into x squared minus 8x plus 12. Substitute the 2 first. You'll see that it's 4 minus 16 is negative 12 plus 12 is 0. You can also substitute 6. 36 minus 48 is negative 12 plus 12 is 0. It's always good to check your answers when you have some extra time and before turning in a quiz. The next one is also quadratic trinomial. However, the leading coefficient is not a 1. So I'm going to do it very similarly to number 5. I'm going to multiply the quadratic term and the constant term. So 2 times 1 is 2. And I'm going to find two factors of 2. The list for factors for 2 is very short, obviously. And find which ones can add to negative 3. It's got to be negative 1 and negative 2. I teach factoring trinomials by splitting the middle term. Your algebra teachers might have taught you a different way, so feel free if you remember how to do it. Some people do guess and check. I know some teachers use something called the box method. Feel free to do it. But what I do is I rewrite the problem, except I replace the negative 3x with a negative 1x and a negative 2x, because if I were to combine these, I'd get the original negative 3x. Remember, while you're factoring, you're not allowed to change the value of the problem, but you're only allowed to change what it looks like. Now I group them in pairs. I find the GCF of each pair. So the GCF of these two is 1x. The GCF of and you can do it individually if you want. Divide these both by x. The GCF of these two is negative 1, or you could divide them individually. And the way I write the solution is the two GCFs go in one binomial. So x was the GCF of the first two terms, negative 1 was the GCF of the second two terms. And then I divide the first two terms by the GCF that I found first. So 2x squared divided by x is 2x, and negative 1x divided by x is negative 1. Notice that you'd get the same thing if you divided these. You'd get 2x and negative 1. They should match. If I were to multiply this out, don't actually write this, but if I were to multiply these out and combine like terms, I'd get the original trinomial that I started with, which is good, because that means that I did not change the value. Okay. So the factored form for this trinomial is x minus 1 and 2x minus 1. After I'm done factoring, I'm going to set each linear term equal to 0. And as you're solving, make sure that you reduce when possible. Whoopsies. Because this was a quadratic equation, it could have up to 2 solutions. Okay, go ahead and continue to the second video if you need help with the second half of the worksheet.